Okay, for our next lesson, we're going to go back to our steel smelting reaction, and we're going to ask ourselves another question. Our next question deals not with the carbon footprint, but what we would call an ecological footprint. An ecological footprint looks at the amount of resources that you take from the planet, and whether those resources are put back or taken out of commission. So in this case, the resource that we are removing from the planet is hematite, and we're also removing carbon. That's another thing that we need to realize, is that this carbon right here that we get for the reaction actually is mined from the ground, and it's mined in the form, typically in the reaction, it's in the form of graphite, but it comes from coal. And it's a specific type of coal. It's called anthracite. And that coal is typically between 92 to 98% carbon. And that's by weight. So 98% or 92% of anthracite, depending on where you take it out of the ground, would be carbon. So we're going to try and answer both these two questions here. How much mining actually needs to be done in order to produce the amount of iron that would be needed for your first car. So I've just given you a basic reaction here, and before we step any further, we have to balance it. That's the most important thing whenever you're given a reaction and you want to do calculate amounts, which is stoichiometry, from that reaction. The first step is always to balance it. Again, key into an odd number oxygen. My rule of thumb is whenever you see an odd number oxygen, you double it, make it even. So here we will double this, which gives me 4 irons. 2 times 2 is 4 irons. Because the iron's attached to the oxygen here, I might as well balance it on the other side. 2 times 3 gives me 6 oxygen, so I'm going to need to put a 3 in front of the carbon dioxide. 3 times 2 gives me 6 oxygen there, and I'm going to need 3 carbons here. Going back to the previous lesson, it was stated that the approximate mass of iron that you would need for the steel in your car is about 820 kilograms. That gives us 820,000 grams. Whenever, again, we do these calculations, we have to convert to grams. In the case of smelting reactions, we're looking at really big numbers. When we start looking at acid-base neutralization and other types of examples, it could be really small numbers. And so that's what we're doing. We could also express this in scientific notation, so it would be 8.2 times 10, and then we just count the number of decimal points we bump. So 1, 2, 3, 4, 5 decimal places we would have to move. So 8.2 times 10 to the 5 grams. Now, in order to solve for moles, which is N, we need to know the mass and divide it by the molar mass. Again, just to flip back to the periodic table, we would find our molar mass of iron by looking at iron on the periodic table and focusing on this number right here. We've called it atomic mass in the past, but now we're going to refer to this as the molar mass. So from now on, whenever we talk about the atomic mass, I will be expressing it as molar mass. Okay, so back to the equation here. So we know how many grams of iron we need for our car. Our molar mass of iron is 55.85 grams per mole. So if I want to find my number of moles, I take my mass, divide by my molar mass. Pretty straightforward. So if I divide that, we've already done this with the last question, so I'm just going to speed this up a little bit. Our number of moles is 14,682.18 moles. Okay, so now let's try and tackle our first bit. We're going to try and tackle the hematite. We're going to try and figure out how much of that ore we actually need to dig out of the ground. So in order to do that, we need to use our molar ratios. So I'm just going to draw a line here connecting one thing to the other, and I'll put the molar ratios on. So we have 2 parts of iron 3 oxide to 4 parts iron, and we can break that down and say it's a 1 to 2 ratio between the number of moles of iron 3 oxide that I need to take out of the ground compared to the moles of iron metal that I produce. So now when I know this, I can take it a step further and use my ratios to figure out my number of moles. So iron 3 oxide over iron is equal to 1 over 2. And I put X as my unknown. I need to solve for my iron 3 oxide. And my number of moles of iron that are produced in the reaction to make my car is 14,682.18. So I will do some cross multiplication. I pretty much just bring my 14,682 up to my 1. So that's 14,682.18 divided by 2. And my number there, my number of moles of iron 3 oxide is 7,341.1 moles. So now I've got some things to work with. So once I know my moles, I can start to work backwards. I need my molar mass. This is going to take a little bit of calculating here. So I need to calculate the entire molar mass of this compound. So I'll break this up into steps. So first I have to deal with my iron. So the molar mass of one iron atom is 55.85 grams per liter, but I have 2 of those. And then I have 3 oxygens, so the molar mass of oxygen is 16 times 3. Okay, and when I complete that calculation, I get a molar mass of 159.7 grams per mole. So I know my molar mass and I know my moles. So in order to find mass, I just rearrange this formula up here and I just cross my molar mass up. So it's my number of moles times my molar mass. A very straightforward equation. So M equals, in this case, 7,341.1 moles times 159.7 grams per mole. The reason why I write it like this is so that I can cancel out, and I can always check and make sure that I'm setting up my equation properly. So moles on the bottom cancels out with moles on the top. So I do my calculation and I get 1,172,000 373.6 grams. So that's 1,172 kilograms and a bit. So that's a large, a fairly heavy chunk of ore that will need to be extracted from the ground. Now you could take this a step further as an extension, and I'll post the work for this up on the web page. I want you to use the density of hematite, and the density is 5.26 grams per cubic centimeter. And I want you to use this density value, and again, density is mass over volume, to figure out the volume of ore that would need to be removed from the ground. And that probably gives you a really good idea of the ecological footprint. I'd like you to give me the volume in cubic meters. And so you'll have to convert from cubic centimeters to cubic meters. So when you first do your calculation, you're going to get volume in cubic centimeters. And so all you need to know that it takes 1,000,000 cubic centimeters to equal 1 cubic meter. Alright, and that is 1 meter this way, 1 meter that way, and 1 meter that way. So it's actually pretty big. To put in a perspective, you could put 500 2-liter pop bottles pour that amount of liquid into a cubic meter. Alright, in the next video lesson, we're going to go through and figure out how much coal, how much anthracite would be required in order to make your car as well. And then your extension will also be to figure out the volume of coal from the ground that would need to be removed.